All right, a little bit more about vectors today. Today we're going to be talking about magnitude and direction of vectors kind of in standard form. However, I understand that we've been talking a little bit about, direction of vectors as far as like heading and bearing works, but now we're going to kind of take, like we were talking about yesterday, where we can sort of plot a vector and then find out where that thing's at or what's the angle, but in standard form, not necessarily heading or bearing, even though that stuff can be still found. But we're going to talk about it, so it connects, and everything that we've been working on in Trig sort of connects together. So the first thing we're going to work on here is what is the magnitude of a vector. And all that really means, magnitude just means size, or how large is that vector. And again, every vector that we're going to draw in class, as far as like putting it on a grid, is going to start from 0, 0. Because we can move a vector wherever we want, we might as well start it from 0. So here is the vector negative 4i plus 7j. So we backed up 4, gone up 7, we're putting that down. So magnitude is the size or the length of this vector, which you guys kind of already know how to do. We're just putting a little bit different terminology, because really this is the same as a right triangle right there, and we'll kind of color it yellow or something like that. And this is 4 this way and 7 this way. So really all you need to do is the Pythagorean theorem in order to find that vector. So really you could take the square root of 4 squared, and I'm going to type these out, I understand, plus 7 squared, just so that we make sure that, we emphasize. And even so, you could put a negative here. It doesn't matter if it's positive or negative, because when you square something that's negative, that will become positive. So then here we know that that is, that's square root, there we go. 4 squared being 16, 7 squared being 49, and then we would say, okay, well, that's the square root, I suppose, of, there's 50 plus 15 more, so the square root of 65 in there. And if you want to change that to decimal form, we'll round to at least 2 decimal places. That's always fine. I just want to double check. Okay, 16 breaks down into 5 and 13, both of which are prime, so we can't rationalize that anymore or reduce this one. Not going to work out. So we can just, go ahead and say, yep, that's how we would find the, make that a little smaller so we can see it. There's the magnitude, square root of 65. That's how big that is. And if you, like I said, if you want to change it to decimal form, round to 2 decimal places, perfectly fine by me. That's how we find magnitude. Pythagorean theorem. That's all it is, right? And it sounds fancy, but not too difficult. Okay. The second thing we want to go over is direction, but in standard form. This isn't heading, this isn't bearing, this is direction in standard form. So here I'm gonna, let's emphasize that, standard form, okay? So standard form, just like any angle now, we're gonna start, going back to kind of our trig ways, where we would go from the x-axis over to here. Okay, that's what we want to find. So in this case, there's lots of different ways we could do that. The most efficient, though, is to use tangent. Okay? Now, we want to find this angle out here. Remember, when you do inverse tangent, it's going to find the reference angle. So we want to be a little bit careful. So here I'm going to take all this stuff. We'll take it out. We do know that tangent of, whatever angle we have, that's going to be opposite over adjacent. So that's 7, because that's the height, and 4. Sometimes people switch that around. They put 4 over 7 because we read from left to right, but 7 is opposite. So really it should be the second number, 7 over 4, right? And I get it's negative 4, but if we're just finding the reference angle, negatives and stuff really don't matter in there. And so then we would do the arctangent, or the tangent with a little -1, the inverse tangent of 7 over 4 in there. And this one, we're going to have, we can't really leave it in that form, because, we're going to need to subtract it from stuff. So we are going to need to use a calculator. So I would just type in inverse tangent 7 over 4. You can check that on yours as well. It's just above 60 degrees, which is about 60.26 degrees on there. Okay. So I'm going to put that in there. Now, do you want to round this to a couple decimal places? That's always good thing to do with angles. Don't just like drop it off. I know a lot of people will just say, oh, 60 degrees. don't just put 60 degrees down, okay? Round that all the way over. Let's move this stuff over a little bit. And so round it to at least 2 decimal places. That's always a good thing to do. So we know in here, I'm going to use one of these guys, if I can get my cursor on it, 60.26. Okay. Again, what we find with this is the reference angle. Okay. That's where that part is. That's the reference angle. But what we want to know is what is the angle out here, which some of you guys are already thinking. Again, I'm drawing these pictures in there to help, to kind of help out. But we want to find out what is the angle here, which should be, 180 minus whatever that amount is, okay? Depends on where this vector is at. If it's in here, we're going to subtract it from 180. If the vector happened to be in quadrant 3, we would add that angle to 180, right? Sometimes we forget about that, but we're going to keep that stuff in mind. Let's make this a little thicker so we can see. This is the one that we're looking for. That's the big thing. So this angle in standard form, either you can think about it, type it in your calculator. I'm just going to do minus 180 and say, okay, that's 119.119.74 if we round that. Okay, so here is where the answer is. So I am going to put this in blue and really big. This is the result that we are looking for. That's the one, not this. This one's right here. And let's put an arrow in there. So just to be clear, this is not the answer, this one here. So hopefully for those of you guys who are watching the video here, for those that like to skip the video, well, they might get a lot of that stuff wrong and then they'll have to redo some stuff. But you guys know, well, let's not make that red, that thing looks the same. But you guys know on here, that's what we'll be doing in that case. All right, let's make that green. All right, well, that's all there. I'll kind of format this a little bit better so that, that should work, right? Hopefully there. But if you guys have any questions on this stuff, make sure that you're sending me an email or, getting a hold of me somehow. A lot of you guys have been doing really good at that. If you do have questions, let me know on that. Otherwise, wish you guys luck, and I will, well, actually, I won't see you tomorrow. Tomorrow is just a quiz, basic quiz over kind of this stuff, asking how do you set things up, maybe a little bit of calculation, things like that. And then after that, I guess you guys have a longer weekend. You guys won't have to log back in until next Tuesday. Okay, so next week, Tuesday, I have 4-day weekend. Enjoy it. See you guys later.